All right. You guys know about fractions, don't you? Good, because now we're going to take a look at adding and subtracting them. However, just to let you know, we're going to be using what are called rational fractions. They're a little bit different, but they work off the same whole idea. The only way that you can combine them together or add them together is to actually make sure that you have common denominators. So, if I look at these two, do I have a common denominator? So if the denominators are the same, then that means that I can add them together. So that means in this case, it's going to be 4 over 2x. Now, next question is going to be this. Can I cancel between that 2 and the 4? Because all that we have is multiplication going on here, the 2 and the 4 can definitely be canceled out. So what we would end up with then is 2 cancels it up here, and I have 2. So the final answer here is simply 2 over x. That's all it's going to be. Not that big of a deal. So let's try this again. Now, are the denominators the same? I got x squared minus 2x plus 1, x squared minus 2x plus 1. They are the same. So all I have to do now is just take care of the numerator. X squared minus 2x plus 1. X minus 1 is going to be x minus 1. Now, just like before, we have to take a look to see if we can cancel anything. When I look at this quadratic, we are going to have to factor it out. So factoring this, I know I have an x, I know I have an x, I got to have a minus 1 and a minus 1. FOIL to double check. X times x is x squared. This one gives me minus 1x. Those two give me minus 1x, which gives me that. 1 times 1 is 1. So we've got it. Now what did I have on top? X minus 1. Can I cancel? Is this x minus 1 that's up here the same as one of them that's down there? The answer is yes. So we have 1 over x minus 1. That is the answer. The same rules that apply to adding and subtracting fractions apply here. Nothing changes. Let's try this one. Are they all the same denominator? And if we see that they are all the same denominator, we can go through, okay, fine, got denominator of x squared minus 4x plus 3. What about the rest of it? Well, it's almost like we don't worry about this. We're just going to take 2x minus x plus 2 plus negative 1. Thing is, though, we have to keep in mind that we're subtracting all of this x plus 2. Sometimes it's a little bit more helpful to write it out with parentheses like that. So this would be 2x minus parenthesis x plus 2 plus negative 1. Put each one of the things that's in the denominator in its own. Now we can see that we have 2x minus x minus 2 minus 1 all over x squared minus 4x plus 3. All we're doing is combining all the little rules that we've seen so far. So, can I add like terms? Well, if I look at this, I've got 2x minus x. Would that just be a plain old x? Minus 2 minus 1, would that be a plain old negative 3? Negative 2, negative 1, negative 3. Last but not least, I got to factor that just to check. We know this is x. We know that is x. That's positive. Negatives here, so it's minus and a minus. So what factors of 3 get us to a 4? 3 and 1. Will x minus 3 cancel with the x minus 3 on the bottom? Does this one up here cancel with that? Boom. So now all we have left is just 1 over x minus 1. Now I realize you're looking at these things and it's just a whole bunch of different numbers that are going together, and it really doesn't seem to make all that much sense. What I want you to keep in mind with this, the rules are the same. If the denominators are the same, we add the numerators together. If we can cancel something, we must see if we can cancel. So, what I want you to do is I'm going to give you a couple minutes, or actually about a minute or so, and I want you to do this one and see what you get. Write it out so that when I go through and write it out, you can see what should have been done and what you did. Are the denominators the same? Yes, I got 5x cubed, 5x cubed. So I know that I'm just going to have 5x cubed on the bottom. 7 plus 3 is 10. Is there anything to cancel? Yes, between the 5 and the 10. So you end up with 2 over x cubed. What'd you get? See, that's good. So I'm going to give you another minute or so, and I want you to do this one. Same rules apply. So ask yourself the exact same question that we did before. Are the denominators the same? So we know that we have x squared minus 1. Now on top I have x minus 1. Can I cancel? I don't know. Because we have a quadratic on the bottom, we must factor. This one is the difference of two squares, so we know that this goes to x plus 1, x minus 1. What did I have on top? X minus 1. Cancels, so I end up with 1 over x plus 1. That's that. Cancel the wrong one, but that's okay. You're seeing what you're doing. Okay, here's one more. Give you a minute or so on this one. Here we go. When we look at this, we see that we have a common denominator. 3x squared plus 19 minus 14. Okay, so it's all the same all the way across. What about the numerator? Well, we have 4x plus 1 minus, and like I said before, you see a minus, make sure that you put parentheses around whatever is there. So now we have minus x plus 3. Continuing on. Well, I got 4x minus x, so I have 3x and I have 1 minus 3 for negative 2. Now, since things have been going the way that we're going, and we're going to have to factor, right? We know that's going to be the case. Questions? I see some of you looking rather perplexed. Oh, just remember, the negative goes on to the x and the negative goes to the 3 as well. Okay. So, 3x minus 2, factor. Well, it would be nice if I could get a 3x minus 2 on the bottom. Let's see if we can actually do that. I'm just going to write this in real quick. So, I know that if I have 3x squared here, and I wrote down 3x, which is what I'm hoping for, this is a plain old x, right? I know I got to get to 14 over here, a negative 14. I have a negative 2, so this is probably going to be 7. Okay, so let's check this out here once. Well, 2 times that gives me negative 7, or negative 14, right? 3 times this gives me negative 2x. 3x times 7 gives me 21x. So do I get my 19x? And I do. So now, cancel this with this, and I end up with 1 over x plus 7. That's the whole answer. Yes, it does take a little bit of time to go through these. So, let's try this. I want to find the least common denominator. So if I have two fractions and I need to combine them together, I need to make sure that I have all of the pieces. Now, there are different ways of doing this. I take a look at this and I see a 2 and an x and a 7 and an x. Well, what happens if I just had a common denominator of 1/2 and 1/7, and I wanted a common denominator for that? What would we use? Besides a number? Eli, what would I use? If I got a 2 and a 7, what's your guess? Your wild guess is absolutely correct. So we would use a denominator of 14. Each one of these has an x, so it would just simply be 14x. That's all I would need to do, is take a look at what I've got here. Least common multiple of 2 and 7 is 14. Let's take a look at these. Now this looks uglier all the way around, doesn't it? Oh, good. So I want to find the least common denominator here. I am going to have to factor both of these. So starting off with the x squared minus 4, well, this is a difference of squares, so this is going to be x plus 2, x minus 2. Now the other one, x squared plus 5x plus 6, we know this is going to be an x, this is going to be an x, this is positive, that's positive, so we know both of these are pluses. So what factors of 6 add up to a 5? That would be 2 and 3. Now, to find the common denominator, I need to have all of the parts to each one of these in the denominator. And what I mean by all of the parts, I need an x plus 2. So I'm going to put down an x plus 2. I need an x minus 2. So I'm going to put down an x minus 2. I need an x plus 2. I have an x plus 2. I don't need another one. I need an x plus 3. Do I have an x plus 3? And no, so I have x plus 3. This is the denominator that we are going to have to use. factor and get the pieces that you need for each one of them. So I'm looking at this one. 6 and 7. Are there any parts in common between 6 and 7 in terms of multiplication? And the answer is no. So that's just going to be what denominator then? What's 6 times 7? 42. Okay. How many x's do I need for the first one? How many are there? 3. So I got to have x cubed down here. How many do I need for this one? 2. Do I have at least 2 down here? I'm done. That's all I need. So I've got the least common denominator now for those two. So I'm going to give you a few moments here, and I want you to figure this one out. All right. I'm going to go through and do it and see if what you have matches what I did. First thing that I've got to do, because they're quadratics, I have to factor. So for the first one, we've got 732 minus 15. Oh, let's see. I think I'm going to end up having to do, I know this has got to be a 7. So that's got to be a x there. This is plus, that's minus. So I know that one is positive and one is negative. Which one is which? Now I got to get to 32. When I think of the numbers that make up a 15, I see that 5 in there, and I'm thinking 7 and 5 would be a good thing to have, right? So if I put my 5 here, 7x times 5 gives me 35x. I need to get to a 32. Okay, that's positive because I need that to be positive. That's negative, and this would have to be a 3. Why? Because 3 times 5 is 15. 3 times x minus 3x, so I get my 32. This is why we practice going and factoring these things out all the time. So let's try the next one. No, it's got to factor out. I know one of these is going to have to be a 2 and an x. I've got to get a 35, but I need a difference of 3. And the only things that make up the 35, 1 and 35, 5 and 7. And I got a 2, a 5, a 7, and a 2. Ooh. How about 10 and 7? So what we're going to try and do here is I am going to put my 5 right here. So that goes together and I end up with a 10x. Then if I go and put my 7 over here, that would have to be negative because 7 times x is minus 7x. And I get 3x. So this over here had to be a positive. So do I have anything that's the same in both of them? And the answer is yes. Each one has an x plus 5, x plus 5. So what do I need? I need an x plus 5. 7x minus 3, I need one of those as well. 2x minus 7, I need one of those. That is the least common denominator. Now, one of the other things that we have to be aware of is where the zeros are. We don't want to go and pick a value for x that's going to make this thing not work. Now, we've already talked about going through and factoring the denominator off and finding where the zeros are at. So this is really what we're looking for. 2x squared plus 4x minus 6, where does it equal 0? Because that's where it will be undefined. So I know I got a 2 here and I got an x there because that gets me to the 2x. I need to get to a negative 3 So I know one is positive, one is negative. I also need to get to a 4. So I got to take a look at combinations that are going to get me to that. So let's see, we'll do it this way. 2 times 6 is 12. What are the factors of 12? 1 and 12, 2 and 6, 3 and 4. So are there any of these that are going to have a difference of 4? Because I need a positive and a negative sign. So the 2 and 6. So I got to aim for a 2 and a 6. Well, in order to do that for a 6, I need to have 1 or 6, 2 and 3. And since I've already have a 2, I'm going to shoot for the 2 and the 3. Because if I put a 3 over here, 2x times 3, 6x. If I put a 2 here, 2 times that gives me 2x. Where do my signs go? Well, this needs to be positive. So this is plus, that's minus. So that's plus, that's minus. Negative 2 times positive 3, negative 6. So now that I am there, we need to identify where the zeros are at. So that means 2x minus 2 is equal to 0. X plus 3 is equal to 0. Add 2, add 2. 2x is equal to 2. Divide by 2, divide by 2. X is equal to 1. Again, we've been doing this for quite some time. Subtract 3, subtract 3. X is equal to negative 3. So the values of x that I cannot use are 1 and negative 3. So I'm going to give you a couple of minutes, and I want you to go and figure out what values you cannot use here. And yes, we will definitely use Noah's suggestions. So, Noah, well, here's a suggestion. What is one of the numbers that I cannot use? 1. Do you have a number written down? Okay. Well, let's pick on, guy is gone. David's not here. Don't have Cole. Kitty, you got a number? Okay. So, well, in that case, I'm going to take 7x squared minus 66x plus 27. I need to factor this thing out. I know that I am going to have a 7x here. That I know. This is positive. That's negative. So both of these have to be negative. So I know them that far. What I need to identify now are things that get me to 66 that are also in that 27 with that 7. So what should I do? Huh? I can't add it. Could probably, if I use a 3 and a 9. Okay. So where do you want me to put the 9? Well, if I put the 9 over here, that will give me 63x, correct? Negative. And if I put this 3 here, that gives me negative 3x, and I end up with 66 negative. Excellent. So that means that I got 7x minus 3 is equal to 0. X minus 9 is equal to 0. Add 3, add 3. 7x is equal to 3. Divide by 7, divide by 7. x is equal to 3/7. That's one of the numbers. Add 9, x is equal to 9. That is the other number. So really this goes back to learning how to factor and know what it is that you should be doing with them. Now, as we continue on with this stuff, let's take a look at this. Now, we are going to have to go through the process of adding these two. And I'm going to show you a method for doing this that works very well. I will tell you this much. This is these type of problems, favorites for college algebra type stuff and for technical colleges. They love this stuff. If you set things up like this is going to be drop dead simple. Let's fill in the blank. Okay? Now, what should the common denominator be for 3 and 6? 6. Yeah. So I need to have a 6. How many x's do I have? 3 in one term. So I need x cubed. And I've got x squared there, so I don't need anything else. Now, this is where the fill in the blank stuff comes in. 6 times what is equal to 6? X times what equals x cubed? X squared times what equals x cubed? Yeah, another x. What you write here goes up here. One times 1x, well, that's just going to be 1x or just x, correct? Okay, I do the same thing again. 3 times what is equal to 6? 3 times what equals 6? 2. So and now I got x cubed and x cubed, that's it. What I write here goes up here. 1 times 2 is 2. Now, the operation here was addition, correct? So that means the final answer on this thing is going to look like 2 plus x all over 6x cubed. Now, I see that 2 plus x, I see that 6x cubed. There is nothing that will factor out. That is it. That is all the more it is going to be. So, let's take a look at another one. Okay. Now, I've got my expressions this time as quadratic. So now we've got a little bit more of a problem here. However, I am going to set this up in exactly the same way that I did the last problem. My only thing that I'm going to have to worry about now is what do these factor into? Well, if I've got x squared minus 1, that's a difference of 2 squares, correct? So that should be x plus 1, x minus 1. Yes? Over here, x squared plus 3x plus 2. I need to factor it out. I know I've got an X and I've got an X. Add here, add here. What is going to be here? Well, I need a 2, add up to 3. Well, that would just be 1 and 2. Now, just like we did before, I need to make sure that all of these parts here are for the least common denominator. I need an X plus 1. So I'm going to put in an X plus 1. I need an X plus 2. So I'm going to put in an X plus 2. I need an X plus 1. Do I already have an X plus 1? Yes, I do. I need an X minus 1. Do I have an X minus 1? No, I don't. X minus 1. So, whatever's here goes up here. So we got to have our common denominators, X plus 1, X plus 2, X minus 1. Now, the question comes, what do I have to multiply this by to get to that? This is where it is even easier than the last time. This is an X plus 1 and an X plus 2. What more do I need? What's missing? I got an X plus 1 and an X plus 2. I got an X plus 1, I got an X plus 2. What's missing? X minus 1. So guess what goes here? X minus 1 and X minus 1. Okay? Same process again. I got an X plus 1 and an X minus 1. What do I need to multiply here to get to this over here? Well, here's the X plus 1, there's the X minus 1. What am I missing? X plus 2. So what's here goes up here, X plus 2. Now, take a look at this. 1 times X plus 2 is going to be X plus 2. Put it in parentheses. 1 times X minus 1. Well, that's just going to be in parentheses, X minus 1. Now, if you are capable of not writing out your work and doing this stuff in your head, this is where it pays off. I need to take X plus 2 and subtract X minus 1. So my question is going to be, what is X minus X? They're gone, right? What is 2 minus 1? 1 over X plus 1 times X plus 2 times X minus 1. Now, you do not need to go through and FOIL that out. Generally speaking, they only expect you to get to this point, and that's it. Okay? So, I'm going to give you a minute or so here, and I want you to do this. Just to backtrack for a moment here, guys, it's just been called to my attention that I can't do simple math. Two minus negative 1. 2 minus negative, that would be 3. Like I said, I can't do simple math. I can do the hard stuff, but not the simple stuff. All right, here we go. Now, set this up. 1 over 5x to the 4th plus 1 over 7x to the 5th. So, common denominator. I've got a 5 and a 7. What would be a good common denominator for 5 and 7? 35. So I got a 35 here and I got a 35 here. How many x's do I need? Well, I got 5 here and 4 there, so that means I'm going to need a maximum of x to the 5th. We only need to make sure that this is here or that is there. So, question comes down to 7 times what is 35? 5. So what's here goes up here. and I get a 5 over there. 5 times what is 35? 7. What am I missing yet? I need one more x. So 7x. So 7x goes up here. Now, 7x plus 5 all over 35x to the 5th. Can I cancel anything out of there? And the answer is no. And there you go.